Good morning, class. We are looking at chapter 3, derivatives. Here's section 3.5, the chain rule, and its third part, part 3, related rates. Related rates. So we covered various aspects of differentiations, and now the chain rule that comes from the composite function resulting in f y prime being f prime of g of x, g prime of x, in Leibniz's notation dy dx, is dy du du dx. As you can see, we have all kinds of differentiation formulas here, from the basics to the product rule, quotient rule, chain rule, exponential rules, everything that we have seen so far. So 3.5, related rates. Here's part 3 actually. So what is related rates? Let's look at the concept. If, as an example, if we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. Procedure. Number 1, find an equation that relates the two quantities. Number 2, use the chain rule to differentiate both sides with respect to time. So the independent variable is t. Therefore, dy dt is dy du du dt in this case. We are going to look at the same situation with numbers as a warm-up example, everybody. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? Bear in mind, when you're doing related rates problems, those are word problems, okay? So we need to understand what's given, what's missing, and then change it symbolically. So what is given? The rate of increase of the volume of air is given to be 100 cubic centimeters per second. What is missing? The rate of increase of the radius. That's what we are looking for. At what point when the diameter is given to be 50 centimeters? So first and foremost, we need prior knowledge of mathematics. In this case, a spherical shape looks like that, and its volume has the formula 4/3 pi r cubed. Whether you're dealing with a sphere or circle, it is true that d equals 2 times r, diameter is 2 times the radius. So this is a piece of information from geometry, algebra, you name it. Now let's go symbolically. So the volume is 4/3 pi r cubed. The rate of increase of the volume of the air is 100 cubic centimeters per second. Please understand, the rate refers to differentiation. So this is dV dt. dV dt is 100 cubic centimeters per second. The rate of increase of the radius, dr dt, is missing. At what point? when r is 50 over 2 or 25 centimeters. R is d over 2 or 25 centimeters. Therefore, we are using this volume and we are differentiating it with respect to time, which means we are using this concept of Leibniz's notation dy dt is dy du du dt. Therefore, in this case, dv dt is dv dt with respect to the intermediate variable. What is the intermediate variable? R. So dv dr dr dt. All right, so we are going to differentiate this function with respect to t, and please bear in mind 4/3 pi is just a number. So dv dt is 4/3 pi times, now r cubed needs to be differentiated, 3r squared times dr dt. That was the only calculus step. And we get 4 pi r squared dr dt. We have a choice. We can plug in, find the missing dr dt, or we can solve for dr dt by dividing both sides by 4 pi r squared. So dr dt is dv dt divided by 4 pi r squared. So let's plug in. What do we have? dv dt is 100 cubic centimeters per second over 4 pi r 25 squared. Now we know the product of 4 and 25 is 100, and it's 25 squared. So 4 times one of those 25 is 100. So you have 1 over 25 pi. Precisely this is an exact answer. Units of the radius over units of the time. So we say the radius of the balloon is increasing because it's positive at a rate of 1 over 25 pi precisely, or 0.0127 centimeters per second. Every word problem, you must answer it with proper units. Example 1, a small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So we need to translate. And the first thing we need to know, we are dealing with a circle and its radius. Therefore, from the center to the circle, this is called the radius. From the center to the circle, as we go both sides, is the diameter. So diameter is 2 times the radius. When we go around it, it's the circumference, conceptually like perimeter of a figure, 2 pi r. The area is pi r squared. That's what we need. We need the area. So I'm giving you all of them because just want to remind you, but we need A equals pi r squared. Now let's go back, reread the question and write the given. A equals pi r squared. So the radius is increasing at this rate. Again, the moment you hear rate, just think about differentiation, dr dt is 3/2 feet per second. What do we want to find? The rate at which the area, that means the ADT is changing, the ADT. At what point when r is 4 feet? So here's the translation. A equals pi r squared, relating the area to the radius. Dr dt is 3/2 feet per second. And we want to find the ADT when r is 4 feet. All right. Let's differentiate. And to differentiate, we want the ADT and pi remains unchanged, is the number, times r squared 2r dr dt. This is the only calculus step. So 2 pi r dr dt, replace the r, replace the dr dt, and you're done. So r is 4 feet, dr dt is 3/2. So we get 3 times 4, 12 pi units of A over units of T, 12 pi square feet per second, exact, and put into calculator approximation, 37.6991 square feet per second means the area is increasing by this much when the radius is 4 feet. This is, again, an exact answer. Okay, everybody? You always need to know the exact answer. Find dy dt for the equation 4x plus 3y to the power 4 equals x squared, where dx dt is 10, x is 4, y equals -2. Now, before we move on, the very first thing we should notice, the independent variable is t because they're asking for dy dt. Therefore, the derivative of y is dy dt, and the derivative of x is dx dt. It's not 1. So let's start term by term. 4x, 4 dx dt. Plus 3y to the power of 4. We follow that. Remember, dy dx of y to the power of n is n, y to the power of n minus 1 y prime. Normally, we have dy dx. So in this case, 12y cubed. But instead of dy dx, we have dy dt, because t is the independent variable. And this guy, 2x dx dt. This is the only calculus that we've done. There are two ways to finish it. One is to plug in, and that's fine. The second one is to solve for dy dt and then plug in. I'm going to show you both ways for practice. So first, let's plug in. That means replace the dx dt with 10, y with -2, x with 4, and simplify. Now this is 40. This is 2 times 4 times 10 is 80. This is -8. times 12 is negative 96. Move the 40. The right side is 40. Divide. By negative 96. Both of them are divisible by 8. So dy dt is negative 5 over 12. You have to put the answer in its lowest term, remember that. Now, and this is fine, we are done. You don't have to do anything else. But I want to show you the second method. That means I'm going to solve for dy dt here. And then plug in. To do so, I need to move this to the right, becomes negative. Again, this is second method. You don't have to do both methods. But the second method has more algebra because we are solving for dy dt. In both cases, this is the only calculus step, the one with the asterisk. You're solving for dy dt. You're going to divide by 12y cubed, but on the right side, take the 2 dx dt out. So you can simplify the 2, and that's the final answer. And now if you plug in, you get to the same answer, okay? Why did I do that? I just wanted to show you maybe the question asks, okay, find dy dt, part A and part B, evaluated with the given numbers, okay? So you should be able to do that. We want to find dx dt. For the given equation 3x plus y e to the power of x equals 20. Where dy dt is negative 8, x is 0, y is negative 1. So let's differentiate term by term. 3x, 3 dx dt. Y times e to the power of x. I put a raised dot in between, and I use the product rule. This is f. This is g. So we need f prime g plus g prime f. F prime dy dt times g e to the power of x plus g prime f. E to the power of x is itself times dx dt class. So it's not just e to the power of x, e to the power of x dx dt, and then times y. Of course, 20 is a number, and the answer is 0. So one more time. E to the power of x. The derivative is e to the power of x dx dt times y. 20 gives you 0. Done with calculus. Again, let me box that. This is the calculus step. Plug in. We are replacing dy dt with negative 8, x with 0, y with negative 1. We are plugging in everybody. Let's see what we get. E to the power of 0 is 1. So this is 3 dx dt minus 8 plus minus minus dx dt. Is to add up to 2 dx dt equals 8, and you divide by 2, dx dt becomes 4. Again, just for practice, I'm going to show you how to solve for dx dt by simply moving dy dt e to the power of x to the right and making it negative. Since we are solving for dx dt, on the left side, we are going to factor it out. When we factor dx dt, this gives you 3, this gives you y e to the power of x. And just make this one the denominator of the right side because you're dividing by it. And at this point, if you plug in, you get the same number 4. Plug in these values. Again, do you have to do that? No, this is the second method, as I mentioned. Let's look at this question. We want to find dy dt for the equation 5x plus y to the power of 4 minus x equals 6, where dx dt is 3, x is 2, y is negative 9. This one I'm not going to do both methods. Let's differentiate term by term. And number 4 sits in front. Same thing to the power of 3. Now, the derivative of the inside by the chain rule is 5 dx dt plus dy dt. So this is the first piece. 4 sits in front. The same thing cubed. And 5 dx dt plus dy dt. That's, believe it or not, the extended power rule. Minus x, the chain rule. Minus x is minus dx dt, any number. 6, 5, any number gives you 0. Done with calculus. Plug in, which means replace the dx dt, x, and y accordingly, and simplify. So 5 times 2, 10, minus 9 is 1. Cube it doesn't change, it's 1. This has no bearing. So just write it. 4 times, again, this thing is 1, so it doesn't change. 15 dy dt minus 3. So when we distribute, we get 60 plus 4 dy dt minus 3. 60 and minus 3 would be 57. Move it to the right, make it negative. 57. Divide by 4. And you're done. Dy dt is minus 57 over 4 as the final answer. Again, you could solve for dy dt here. I'm not going through that second method. I highly recommend you do it for practice. Example 5, falling sand is forming a cone-shaped pile. The volume of the cone is increasing at a rate of 54 pi cubic inches per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. A cone-shaped looks like this. The base is a circle of radius r. Here's the height. And the volume is increasing and the rate at which the radius changes. We have to connect the two with the formula volume is 1/3 pi r squared h. So we should know this from prior knowledge of mathematics, geometry, algebra, trigonometry, whatever you want to call it. So now that we have the volume and its formula, let's reread and write the given. So the volume is increasing at this rate. dV dt is 54 pi cubic inches per minute. The height is twice the radius. H equals 2r. H equals 2r. Find the rate at which the radius changes when the radius is 6 inches. So you want dr dt at what point when r is 6. So here's the recap. Here's the formula for the volume. dV dt is 54 pi cubic inches per minute. The height is 2 times the radius. We are interested in finding dr dt at a precise moment when the radius is 6 inches. That's given symbolically. All we have to do, differentiate this. But before we do that, we notice we have two variables on the right side, r and h. And if we want to differentiate, we have to use the product rule by the way. However, they are asking in to find dr dt, and h is 2r, so I can replace the h with 2r. By the way, because they are asking for dr dt, I'm going to replace the h. But if they were asking for dh dt, I would replace the r. And by the way, if h is 2r, r is h over 2. So replace the h with 2r first. And the product gives you 2/3 pi r cubed. And now the right side is a function of only one variable, r. So dv dt. Now we're going to go to differentiation. So we're going to start with the calculus. dv dt is this number, this is the number, 2/3 pi times the derivative of r cubed, 3r squared dr dt. 3r squared dr dt. And this is the only calculus step. Everything is prior knowledge of mathematics, algebra, geometry, you name it. We are going to rewrite this as 2 pi r squared dr dt, and we are going to plug in, or we can solve for dr dt by division, by dividing by 2 pi r squared. Either way makes no difference. So replace the dv dt with 54 pi and replace the r with 6. There's the 6 times 2, 72 pi dr dt, divide both sides by 72 pi. The pi's cancel each other. 54 and 72. I hope you recognize both of them are divisible by 9. They are also divisible by 2, which makes them divisible by 18. 9 times 2. And so when you divide by 18, you get 3, you get 4, 3/4. The units of r over the units of time. 3/4 of an inch per minute, meaning when the volume of the cone is increasing by 54 pi cubic inches per minute, the radius is increasing by 3/4 of an inch per minute when the radius is 6 inches. So let's move on. A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. So here's the building or the wall, here's the ladder, and it's moving this way, creating this shape, a right triangle, and this one is moving down like so. The ladder is fixed at 20 feet. This is not changing. As this moves this way, creates the speed or rate of dx dt equals 2 feet per minute. As this moves down, creates the rate or speed of dy dt, which is missing. According to Pythagorean theorem, a squared plus b squared equals c squared. So the formula for us would be x squared plus y squared equals 20 squared. So what is given? Dx dt is given. The formula from geometry or algebra, x squared plus y squared equals 20 squared. We are looking to find dy dt at what point? When the base is 12 feet, when x is 12 feet. This is translation into symbolic format. So all we have to do, differentiate this piece with respect to t. This gives us 2x dx dt plus 2y dy dt. This is a number. We know it's 400, but doesn't matter. Any number gives you 0. Plug in. Now, to plug in, we have the x, we have the dx dt, but we don't have the y. So if you plug in 12 here, at the moment that x is 12, we can figure out the y. So to do so, we plug it here. And so this is 400. This is 144. Gives you 256. And y becomes 16 feet. Now we can plug in. 2 times 12 times 2 plus 2 times 16 dy dt. And 2 times 12 times 2 is 48. 2 times 16 is 32. we move the 48. To the right side, we make it negative. We divide both sides by 32. We drop a common factor of 16, negative 3/2 units of y over units of time, feet per minute. So when the base is 12 feet, at the moment, dx dt is 2 feet. X is increasing, dx dt is positive. At that moment, y is decreasing, dy dt must be negative, and it's negative 3/2 feet per minute, which means at the moment, y, the rate of y is decreasing by 3/2 of a feet per minute. Now, I want to go to the next question, which is continuation of this. And what I want you to notice as this happens, this angle and this angle change also. We're going to discuss that. So the same question, a 20-foot ladder leans against the building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the angle between the ladder and the ground when the base is 12 feet from the building. In other words, just the same as before, the building, the wall, here's the ladder, moving this way, creating this shape, y coming down, and the C is fixed at 20 feet. As it moves this way, it also looks at this angle changes, this angle plus this angle changes. So does this angle. Okay. However, this is the angle between the ladder and the ground. This is what we want. This is the angle between the ladder and the wall or the building. So distinguish between the two. That's why we need this one. So as it moves this way, creates the speed or rate of dx dt equals 2 feet per minute, and theta changes, it creates d theta dt, which is missing. We are looking for it. So the given that we put in the previous page repeats with addition of this concept, which I'm going to go over in a moment. So dx dt is 2 feet per minute. X squared plus y squared equals 20 squared. We need that to find the wall. We already found it. But assuming this was an independent question, we didn't have the previous one. And we want to find d theta dt now when x is 12. So in a related rate problem, we relate two quantities. In this case, which one? The one that is known and the one that we are looking for. We are looking for d theta dt, but we are given dx dt, so we are going to relate x and theta. And remember, sine theta is the opposite over the hypotenuse, and cosine theta is the adjacent over the hypotenuse. So sine theta is y over 20, whereas cosine theta is x over 20. Now, you can choose to work with any of them because we found y, but we better stick with the one that we already have. Remember, we already have from the previous page the value of y as well as dy dt. But what if we didn't? That's why you want to stick with the one that is known. You want to stick with x. That being the case, let's work with cosine. We are going to differentiate both sides. And I remind you how I do that. I read cosine and I pause. I say the answer is negative sine. But negative sine of what? The same argument, negative sine theta. Because theta is not an independent variable, we need d theta dt. The right side, if you recognize this, that x has a coefficient of 1 over 25, If not, rewrite this as 1 over 20 times x times dx dt. Okay. Now, all we have to do, plug it. And I'm going to remind you that in the previous page, we found y to be 16. Why is it important? Because sine is y over 20. So sine will be replaced with 16 over 20. Dx dt is 2. And of course, you are dealing with fraction on the left, fraction on the right. And since they have the same denominator, you can just drop the common denominator of 20, which results in negative 16 d theta dt equals to, divide by negative 16, you get negative 1 over 8. Now, the units of theta over units of time, and units of theta, it is always in radians in calculus, unless otherwise mentioned. So negative 1 over 8 radians per minute. Again, as x increases, theta decreases. That's why it's negative. Example 8, a spherical balloon is deflating or losing 8 cubic centimeters of air per minute at the moment when the radius of the balloon is 20 centimeters. How fast is the radius decreasing? Here's the shape, here's the volume. We are supposed to know that. So the volume is 4/3 pi r cubed. What is given? dV dt is negative because it's losing, it's deflating. It's losing air, negative 8 cubic centimeters per minute. How fast is the radius decreasing? That means the RDT at what point? When R is 20 centimeters. So this is the given symbolically. And this is the formula, comes from prior knowledge of mathematics. The VDT is negative 8 cubic centimeters per minute. The RDT is missing and R is 20 centimeters. So we are going to differentiate this. We've already done that. Remember, 4/3 pi is a number, everybody. So dV dt is 4/3 pi times now r cubed gives us 3r squared dr dt. Therefore, dV dt is 4 pi r squared dr dt. We can solve for dr dt or we can just plug in. So I'm going to just plug in, replace the dV dt with negative 8. And r with 20. Twenty squared is 400 times 4 becomes 1600. So this is 1600 pi r dt. We're going to divide both sides by 1600 pi. 8 goes away, becomes 1. 16 becomes 2. So we have the RDT is negative 1 over 200 pi units of the radius, centimeters, over units of time, minutes, precisely. So the answer is negative 1 over 200 pi centimeters per minute. That's an exact answer. And roughly, using a calculator, we get negative 0.001592 centimeters per minute. As far as the number of decimals, if they don't ask you, give them the exact answer. If they do ask you, make sure you have your exact answer in your notes, and then however number of decimals they ask you. Also, Because it says how fast is the radius decreasing, the answer you give back is positive because decreasing means negative. So, okay. So negative means if the question was how fast is the radius changing, then you would say negative, meaning it's decreasing at the rate of 1/200 pi centimeters per minute precisely, or 0.001592 centimeters per minute. So when you explain it, you don't put the negative number, you just say decreasing for negative, increasing for positive. That's how it works.